Nakama. Today we have to talk about how to organize a large program. So I have created a folder for this video. I have to open it as a project. So it's this folder. I open it because I want to see just the concerning files for this video. So generally we have a main source code file. Okay, it is the entry of your program. It is your where you have your main function. Okay, this function called all functions of your project, and then you divide your project in different files for different features. For example, here I've created calculus.c. It is about features about calculus. Okay, I've created a function. So you have source code file. Okay, terminates with .c is the extension, and you have .h file. .h file is header file, and then header file. In header file you have a system header file. So we call it this notation is it's all header files in your standard library when you install your C compiler. And then this notation with double quotes, it's about all header you have defined yourself. But you can use this notation when you make your header file recognizable. When you make your header file like a system file. Okay, we will say it later. It's not the objective of this video. So this file is located inside my computer. Okay, because I've installed the C compiler, so it is inside the user. I think user include. Okay, and you can locate sgio.h. I can search for sg. Okay, it's here, sgio.h. Okay, it's inside your computer. So all those header files of the standard library of C, those files is located inside your computer. But you don't have to do something like this. Okay, with the absolute path. Okay, to locate this header file, but you just use it because this file is indexed by your system. Okay, there is a way to make your own file indexed by the system. But for our project, it's not necessary. You don't have a necessity to do it. Maybe sometimes, but you don't have this necessity. And I have, for example, this 3d/triangle.h. It is the absolute path. Okay, because inside my project I have a folder, and inside this folder I have my triangle.h file. Okay, so when you have to include those header, you have to use the relative path. Okay, that's the absolute path because you start from the disk. Okay, the first slash is about your disk storage, and then you put the path. Okay, you add the path of your file, user include, and then your file. That is absolute, but this is relative. Okay, because we start from this folder. Okay, the current folder where we are actually. Okay, so generally you can have, for example, here /, to say inside my the current folder. Okay, search for calculus.h. Okay, and then the directive include it. So, but you can omit it. There's no problem. Okay, so the same thing for this. Inside the 3D folder, search for triangle.h. Okay, and if you want to go to the parent folder, you have to do two dots like that. Okay, for example, if I want to include a file inside my parent folder here is Okay, let me go. My parent folder is Cprop tutor. Okay, so that is my file where I am actually. And then if I want to, for example, to include a C file, okay, this function.c. If I want to include it, I have to do two dots like that. Okay, two dot means I'm there actually. Two dots means I go back. Okay, I go back and then I precise the file I want to include. So function.c. Okay, so you can include a source code file if you want, but generally we don't do it. Okay, generally we just include header file because we just work with prototype. Okay, like here, that's a prototype. It's not the definition, it's just the declaration of function. So the header file contains some declaration of function, global variable, macros, okay, all those things to just use it after, okay, without search to how this function works. Okay, you have the prototype, you know you have to call this function, for example area with two integer. Okay, and uh, the features, okay, the behavior of this function, okay, the code of this function is not your problem. Okay, you just use it. So that's the role of header, to see all definition and declaration. So when you declare a function like here in calculate.h add, okay, to add two number, um, you don't have to precise the name of the of each argument. Okay, generally I prefer to write like that, but you can precise if you want. Okay, but there is no problem if you omit the identifier of each argument. And then to implement it, okay, you have to implement inside a source code file, C source code file, not inside the header. So I've created this file, calculate.c, to implement this. Okay, so this function do return number 1 plus number 2. And here I've precise the identifier of each argument because I have to use it inside. Okay, but here you can omit. So when you do it, okay, when you create the C source code file of an header, of a header, you have to use the same name. You can use another name, any name you want, but generally you have to do this. You have to use a same name to make a relation between those two files. Because if you use another name, you cannot remember if this file works with this header. Okay, so it's better to use the same name and then the extension is just different. And at the end you can use those function, okay, because you have include the header file. So the header file include the prototype of the function, but the definition is here. So when you compile, you have to compile with the two file or all the C source code file. So main.c and calculate.c. Okay, you precise those all file and then you precise the executable. Okay, the output, the file or the file and the output. Okay. Okay, there is a problem with main because I've included this. Okay, when you include a C source code file, you have to pay attention if this source code has not a main function. Okay, because inside your project you have to compile with one main function. If you have two main functions, this is a problem. Okay, that is why I've tried to include the expression.c inside inside the parent folder. Expression.c is here. Okay, actually I'm here, okay, in my project, so I've do the two dots to include it. Okay, two dots to go back and then include it, and then I've precise here. Here it's just an example. We just have to include header files, okay, not C file. And I'll put it in comment because if I leave it, there will be a problem, okay, because there is a main function inside. So we compile it, okay, it's okay, and then I can execute, it's okay. The explanation is just I declare two number with two values, and then I declare a result. The result take the returned value of the function. Okay, I call this function with x and y. So 2 and 3, and then 2 plus 3 give 5. So the result take 5, and then I print result equal the value of the variable result. Okay. That's all for this video. So the last thing I want to show you is about Makefile. So I have a picture, so I have to go back to the parent for the CPROC tutorial. I have a screenshot in images. Okay, Makefile. Okay, Makefile is a tool to permit you to do a small script to manage compilation. So like last time you have do something like GCC, okay, and then a list of also C source code file. Calculus. Let's see, okay, we have do something like that, okay, and I've beside the output, the name of the output. So when you have very many files, it's not efficient because sometimes you create the new file, sometimes you remove, sometimes you modify, but sometimes there are many files done modified, like for example, I can modify calculus.c but not main.c, okay, but I compile with all those files. It's not efficient. There will be take too much time, okay, to do something like that. So Makefile permits you to manage it, like it verify if a file has modified, okay. If one file is modified, okay, we call it the dependence, okay, the dependence of some destination, okay. If one of these dependencies are modified, you can compile, okay, this, and you have different comparison. So you have different level. The first level is about the object file, okay. We go to the top is the executable file, okay. It is the last file you will get, and then when you go down you have the object file, and then you have maybe another in another language you have another type of file, okay. But we go to the most last destination, to the most dependence, okay, something like that. Anyway, we have a playlist just for Makefile, okay. I just want to speak about it because we talk about how to manage a large program. So when you have a large program, you cannot compile just like that, okay. It's very important. So you have four destination files. So those three destination files about the first level, okay, the first level of comparison. I've talked about it when you have to get the object file and the link those object file to get the executable file. You precise with the -c, okay, to get the object file. So the context of this program, of this code, is a program to manage a text, okay. To arrange a text, like manage a spacing between two words, or manage a break line. If the last word in the line is too long, I go directly to the new line, something like that. So those management, okay, it is the purpose of this project, okay, a small project. I don't have the source code file, but it's just for explanation. So we have three source code file: justify.c. Justify, I think, is permit to manage spacing at the left and right to a word. Word.c manage the word itself, like maybe automatic correction, something like that. And line.c manage the break line, automatic break line, something like that. So we have three source code file, and then if I want to get the object file, I verify if the source code file has modified, okay, before to compile. So it look like a condition. I verify for uh, those three dependencies. We call this part dependencies, and then here target, okay, target or destination. So dependencies, we have three dependencies for justify.o, justify.c, the source code file, word.h, and line.h. I think it's because the justify works on all the file, like the word and line. That is why we need some function from word.h and line.h, and then we need, of course, justify.c, because we compile it to get justify.o. So we verify if one of these files is modified before to compile, and the same thing for word.o. But word.o depend of word.c and word.h, not line.h, okay, because a word just need just to work inside a word, and the same thing for a line works just with line, but justify works with the twice. So um, the powerful of the power of makefile is, you can compile just a part of your program. You don't compile everything, okay. You get very big time, because when you have many files, the compilation take very long, okay. So it's very powerful when you modify just one file. Yeah, the compilation, for example, if I modify the word.c, when I compile my program with makefile, so makefile, if you want to use makefile, you have to create a makefile. So if a makefile file, okay, makefile, I create it here. The name of this file has to be makefile, okay, not another name, makefile. Or generally you can have M in capital letter, so makefile, and inside you have your script, makefile script. So it is this script, okay, and you write it inside the makefile, and when you want to compile, okay, you just do makefile, you just write makefile, and your project will be compiled. Makefile, you just read it and you execute it. When you execute, I think it's okay, let me check. It's not the objective of this video, but I want to show you quickly. Okay, anyway, we see. I forgot the comments to compile, but I think it's okay. It's make. I think it's make. Okay, it's make. So I have execute this make, and then make me say me no targets, stop. So there there was not compilation here, okay, because inside my makefile I have not roles. So each line here, we call it roles, okay. So we have four roles. The first role is line.o. So we go at this sense, okay, to the bottom, from bottom to the top, okay. That is the first role, second role, third role, last, fourth role. Now the first, okay, to compile about line, okay, to compile about word, to compile about justify, to compile about, okay, justify executable. So if I do just make, okay, the command make, like I have do it here, the make take as argument the top. Okay, that is why I call it the top destination. So when you do this comment, you give a argument of the target. So make justify dot o, okay, for this target, or make what dot o. Okay, you precise the destination you want to have, and then make file verify the dependencies and compile it if those files are modified. If it's not, no compilation. So we talk about it. It's not important, but it's important to know it now. We can stop here, and see you for the next video. Nakama, take care of you.
Je refais le portrait comme au Beaux-Arts, loyal, poli, droit et sincère. Je respecte le code du Bushido. Mais si on met les armes à terre, c'est pour te faire une prise d'aïkido. Et la concurrence au cimetière, ne pensez pas mourir aussitôt. Mon katana taille leurs artères et broie leurs organes génitaux. Quand j'étais gauche, j'en ai pris des coups, j'en ai dans le ventre comme un seppuku.